So what you're looking at here is a completed Airfield T-28 kit-only airframe from NitroPlanes. Total build time on this plane was about 6 hours. Most of the time is spent doing the landing gear, mainly the linkages and getting everything working and timed out correctly. So really the reason that I went with the kit is because I had most of the electronics on hand. The airframe does require 12 servos. Most of those servos are 9 gram, just mini servos essentially, micro/mini. And the other thing that I had was I had a motor on hand. You can't really see it because it's behind the cowling here. But the motor I used was a 50-55 millimeter 400 kV motor that's spinning a 14x7 master air screw prop. You can see the prop is nice and balanced, and there's really no vibration to the airframe at all. So spent some time balancing everything out and making sure that the prop adapter was flush, the prop shaft I should say was flush with the motor, which is important for 3-blade props because they can actually end up running out of track if you don't check the flushness of the prop shaft to the motor. So overall the plane weighs about 5.5 pounds without the battery, and if you look on NitroPlanes website, I believe the flying weight is supposed to be around 4.5 pounds, but usually you can easily add or remove a pound of weight and the plane will still fly real well. So because this will be running on 6S, it's going to have to be fairly powerful setup. Draws about 1,300 watts total when the motor's at full throttle. You can see there's neat looking LED lights on the wings and a nice looking canopy hatch which pops right off from the rear end. It's just a great looking plane. Build wasn't too bad. Just have to keep in mind that some parts in the kit aren't included. The left and right linkages for the left and right gear hatch doors on the bottom underneath the wing, they didn't include any linkages, so you have to make your own for that. The way I did it was using easy links and basically some music wire to accomplish the linkage. I'll show you that a little bit. So for those of you who ordered the kit, the most tedious and cumbersome part of the build is definitely the landing gear assembly. Airfield has done a fairly good job including most of the parts you need. However, they don't, at least for my kit, they didn't include the control rods and linkages for the left and right gear hatch doors. So I had to come up with those on my own, and it wasn't too difficult. As you can see here, I used mini easy links and basically some music wire, which is bent at a 90-degree angle, basically to act as a control linkage for the right and left gear hatch doors. The front nose wheel gear, all the hardware is included with that. However, the only thing I added was a little wire retainer there to keep the nose wheel from binding when it extends and retracts. Other than that, I mean, this again takes a few hours to get everything set up properly. I actually had to use a reversing Y harness for one of the gear hatch doors because the servos need to move in opposite directions. As you can see, they're mounted basically in the same orientation, so you need to have a reversing Y harness on there, or you won't get proper movement. You won't be able to move the doors open and closed correctly. They'll want to move in opposite directions, which isn't good. So let's give you a little demo here of how the gears work. So basically, there's a gear switch on your transmitter. Here's what it looks like on the DX7, and let's throw the switch and watch what happens. Now, so as you can see, now in flight, all of the gear hatch doors are closed. This obviously improves the aerodynamics of the plane in flight, and a lot of people say that it's a noticeable difference. Now, one of the things you can probably hear in the background is there's some servo buzzing going on. Don't believe that's going to be problematic. It's just that what I think is happening is the sequencer is simply extending those servos beyond 100% travel. So They do tend to buzz a little bit. I'm not sure again why they do it, but it shouldn't cause an issue. And this is really not the position that they stay in. Most of the time the gear doors are obviously going to be open for, you know, your takeoff, your landings, and if the plane is just sitting out on asphalt or a driveway and you're just testing it, your gear flaps are going to be open. So let's go ahead and pop those gears open and show you the result here. So as you can see, hatch doors open first, landing gear extend, and it's really all there is to it. Again, there's a sequencer that's part of the kit that controls the delays that are necessary for getting the hatch doors open first, the gears coming out when they actually extend. The gear doors and hatch doors, I used HXT 900 9-gram servos, and again I had to use my own control rods on the hatch doors because they weren't included in the kit. The kit did include the control linkage and rod for the front nose wheel gear, and I'll show you how that works. As you can see, when the wheel goes down first, the bar actually turns and the two control rods pull down on those doors to shut them. So let's pop this back open. Again, a very neat retract system. It's probably the first plane that I've owned that had retracts that were this detailed. So they weren't all that fun to set up. It was complicated, and again, the instruction manual doesn't really tell you how to connect them. So it's something you either have to look up by reading through the forums that are out there, or you know, if you've worked with other FMS or Airfield models, then it might be more straightforward. So what I've really done with this kit here is, what you see in the wiring is mostly stock wiring. You have a sequencer in there, and you can see that Airfield has labeled all of the wire connections. The sequencer has 5B and 5C, so the landing gear actually hooks into the 5B connectors, whereas the hatch doors actually connect to 5C. This is because the doors are designed to open in a sequence so that when the gear extend, the doors open first and then the gear pop out. That's while you're in flight, and while you're on the ground ready to take off, the gears will pull in first, followed by the flaps, followed by, I should say, the gear hatch flaps. I used 2 digital servos in the rear for rudder and elevator. This is a little bit different from the stock setup, which just uses a 9-gram. Decided to put some Gorilla Glue in there to reinforce it. So it foams up a bit, but it's really strong, and it's somewhat flexible, so it's not brittle like epoxy and other glues that can break from vibration. So just another view of the underside here to show you. I use the digital servos on the wings and flaps on both sides. And again, you can see your LED lights that are on the wings, and there's your bottom strobe light. The strobe lights actually hook into channels 2 and 4 and just feed off the power connection that are So again, a quick modification that's good to do for the rudder is to actually put a CA hinge. As you can see, I have a hinge in there right at the bottom. All you have to do is take a X-Acto knife and make a cut through here, and I cut a Great Plain CA hinge in half, popped it right in, put some thin CA on it. You can see there's no play in that rudder anymore, so it did the job.